Welcome back. So, last week we learned all about what an archaeologist is. We learned what questions to ask when looking at historic artifacts, such as what is this? How is it made? Why was it made? Who made it? What does this tell me about the people who made or owned it? And we took our third visit to the Met and learned about the human-headed winged lion from ancient Assyria. So, this week, we're going to learn about how science, technology, engineering, and math are used at the museum and found in art and artifacts at the museum. We will learn what the difference between science, technology, engineering, and math is, learn how STEM skills like problem solving are used at the art and the museum, learn how knowledge of math, chemistry, and engineering is helpful when working at a museum, and we're going to look for mathematical patterns in art. We're going to start by discussing the difference between science, technology, engineering, and math. You may have heard the acronym STEM or maybe STEAM, where they add an A for the art. But sometimes STEM is used so much that we forget that these areas of study all have different definitions and goals, even though they very often work together. Science is how we learn and understand the world around us by asking questions, observing, and experimenting. Engineering is applying what we learn and understand about the world around us to solve problems or to make things. And technology is using science and engineering to make products and processes that will make life better. We'll explore math later. So, how are these found at a museum? Let's start with science, because science is really more of a process or a set of steps to fix a problem or find an answer. You may have already learned about the scientific method. Ask a question, research the topic, form a hypothesis, test your hypothesis through experimentation, collect and observe your data and results, and form a conclusion. And of course, at the end, share your report or your findings. So let's pause for a moment and start a quick conversation. I have two questions for you. How do you follow the scientific method like a scientist in your everyday life? And do you think artists could be scientists? Let's take a look at this chart. It compares a scientist's process of looking for a solution to a problem or an answer to a question to the process that an artist goes through when creating a piece of art. So, they ask a question, and an artist might find inspiration. Researching the topic, the artist might research the topic or ideas and methods and techniques. Forming a hypothesis or brainstorming and practicing the techniques. Testing the hypothesis, experimenting would be creating the work and maybe practicing a lot. Observe your data and draw conclusions, reflect and revise the work, and share or report your findings, which would be to present your work. So in a lot of ways, an artists are using a process very similar to how scientists are to better understand and share what they understand about the world around them. So let's watch this cool video from the Met Kids Animation Lab and see how they use the scientific method and this creative method process and see how maybe they use them both at the same time. Okay, so here we go.
Animation to me is when you make something that doesn't look like it's made in real life come to life. We're learning about these composite creatures for our animations.
And a composite creature is like a mixed creature with something else. With another creature or a human or anything.
Right now, I'm doing the crown for the Ganesh close-up. Our composite creature, we're called the Winged Runner. And for our animation, we made the Winged Runner into a female.
and we also did some research on the thing, so we knew what we had to do.
My favorite part of this week is when we went to the galleries.
It was more fun working on the computer and with the clay. I really liked that the best. I learned how to do that. I learned how to make a movie with clay.
So to animate, we had to do little actions by little. So first action, like a little kind, and then take a picture. Another action, take a picture, and so on.
Yeah, it took a long time to make each one.
Oh, I liked the whole week. It was really cool. The drawing and the colors and the different things, and it was so much fun.
Ganesha and the Sphinx are composite creatures. Ancient composite creatures, to be exact.
Oh, that was great. So, as far as I could see, they were using kind of a combination of the two. First, they had to solve a problem, or answer a question. And the question was probably, what is a composite animal? And how can we recreate that using animation? And then they did a lot of research. They researched what those were. They went to the source material, figured it out, and then did a lot of experimentation by trying out new techniques, and they built on it and practiced, and then they were able to look at it and figure out, yeah, this is what a composite animal is, and this is how we would show it in animation. And then they shared their work. So it was a pretty clear combination of both the scientific process and the creative process. So now we're going to look at scientists. Did you know that there are scientists that work at the museum? Yeah. So they're called museum or art conservationists or conservators. A museum conservator is someone who documents, restores, and preserves artifacts that are on display in museum exhibits. They use chemical and physical tests to determine the age and makeup of different artifacts, and use problem solving to determine how to restore and preserve the objects as well as estimate how much it will cost to make those necessary preservations. So let's learn how they fixed the statue of Adam in this video.
Hi, I'm Owen, and I'm 10. Today I'm here with Carolyn. She's a conservator here at the Metropolitan Museum of Art, meaning she restores broken statues.
Hi, I'm Carolyn Riccardelli, and I'm an objects conservator at the Metropolitan Museum of Art.
I am here to talk with Carolyn, and hopefully she'll answer some of my questions about Adam.
This is your first time seeing it?
Yes.
What do you think?
It's a really interesting piece. You can get a lot out of his expression and the way he's positioned, and I think it just tells a story in itself. I hear there's a really interesting story behind Adam. Can you tell me what it is?
This sculpture fell down onto the floor and broke. And it was a very sad day, but here he is back in the gallery. We cleaned it up in a very organized way because we wanted to make sure we always kept track of the fragments that were close together, sort of like an archaeological dig.
It broke around the ankle, right?
It did. The sculpture basically came away from its base.
By the way, how much exactly does Adam weigh?
The sculpture weighs about 780 pounds.
That's a lot. So why was it so important to put Adam back together?
Well, this sculpture is a very important work of art from the Renaissance. It's actually described by art historians as the first monumental nude of the Renaissance that looks back to ancient examples of sculpture, like the Greeks and the Romans. So he's really important. He's like a turning point in art history.
So it was really important for the museum to get Adam back together.
I put out for you most of the things that I use to work on Adam, tool-wise and some materials. And this is what we use to put Adam together. We like very tiny, precise tools.
Do you recognize this for your dentist's office?
This is one of the very common tools that a conservator uses, and it's a bamboo skewer. This is something that you can actually touch. You can pick up that arm.
Yes, that's heavy.
It feels heavy, right?
Yeah, it doesn't look heavy, but it's really heavy.
That's a model of Adam's right arm. With a lot of stuff, we practiced a lot on it, so there's stuff all over it. But this is why we used the model, because we didn't want to get the sculpture dirty or get any adhesive on it until we knew exactly what we're doing.
Well, some conservators' technology is really high tech, like the laser scanning, the computer animation. Some of it is just bamboo stick and cotton. It's one of the best tools. To be a conservator, you need a lot of knowledge about tools, from something really simple to something like a 3D scan. You need to know chemistry. You need a lot of talent and skills. I'd recommend that you come to see Adam, because with Adam you can really admire the sculpture, how the conservators put all the pieces back together, and you can really look at it and see how big a deal it is that conservators are here to help restore priceless pieces. They're heroes of the Metropolitan Museum. This is Owen reporting from the Objects Conservation Department.
That's awesome. So yeah, conservators are scientists that work at the museum, and they work at most museums. You're going to find someone, because one of the main things that we learned in our first session together is that museums are there to conserve and preserve art and history so that future generations can continue to learn about the world around us, just like scientists. So now it's time for everybody's favorite subject, math. So mathematics is the study of numbers, shapes, and patterns. Now, we see patterns around us all day, every day. Patterns are everywhere. The pattern behind this definition is called the golden ratio, or the divine ratio, and is a visual representation of a sequence of numbers called the Fibonacci sequence. Where have you seen patterns like this before? So we're going to go back to the Met and look for patterns. But first we need to learn about the rule of thirds. And we're going to do that by watching Art 101, the rule of thirds.
The world, the universe, this baby seal. Everything can be broken down to a mathematical equation, and art is no different. Let's talk about the rule of thirds. Hi, welcome to Let's Create Something. Today we're going to be talking about the magical rule of thirds. It's really not that amazing. It's really simple, actually. It's just this. You divide the picture into thirds, and then where they intersect, those points, you want to put your subject matter on those points to make your picture better. Why? Because of math. That's why. For whatever reason, we as humans, if you put your subject matter on these points, it just seems visually better. Again, why? Because of math. That's why. And not only is it putting your subject matter on these points, but it's also using these lines as ways to break up your picture. For instance, this right here, it doesn't have to be exact again. You just have to be somewhere in the thirds. So you can use this like this, like this, like this, like this. All thirds, it all counts. All good. Now you can get around this with flat images like pictures or paintings. You can get around this by using balance or symmetry. Because we as humans like things that are symmetrical. Why? Because math is power. Now that's with pictures and flat images and paintings. However, with video and cinematography, you kind of want to keep to the rule of thirds. Not so much as keeping your subject matter in those points, more as using, people or the horizon line to act as those breakup points, those lines. So, like this, like this, like this, and like this, and like this. In most movies, you won't notice, but if you really look at it, you'll see that every shot is broken up in some way with the thirds rule. And again, it's because it just looks better to us as human beings. For whatever reason, we can plot it out math. There's a number. It's like 3.33 something, 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 whatever. But if you follow this rule, it just makes it look better. Again, of course, you can always break these rules, and people do. And sometimes breaking the rules, it looks wrong, so that's interesting. However, if you're just going to start, or if you just want to, get something that looks good really quickly, this is an easy rule to follow. Follow the rule of thirds when setting up your pictures, your paintings, or your video. So yeah, that's pretty much the rule of thirds. Like I said, it's very simple and easy to follow, and it'll make things look way better. So thank you for watching. Please subscribe. If you have any comments, questions, concerns, please leave that in the box below. Don't forget to check out my other channel, Beast Puff.
So, there we go. The rule of thirds. Seems pretty simple. It's basically just the way that we see the world. We're always looking for patterns. And if we provide a very simple pattern for us to look at, it's easier for us to enjoy the painting. And it helps us understand where to look in the painting as well. It's just visually pleasing. And it's all about the mathematics in it, the patterns, and there's definitely numbers attached to it. So what we're going to do now is we're going to go back to the Met, and we're going to look at some famous paintings, and we're going to see if they use the rule of thirds. So here we go. The first thing we're going to look at is one of the most famous paintings of the 20th century by Claude Monet called Water Lilies. Now, Claude Monet painted water lilies more than 250 times. So as far as an experimenter, he experimented a lot with water lilies, which made him quite the expert on how to represent water lilies and what he saw on the painting, either the light or the reflections. He was able to do that a lot because he practiced a lot and experimented a lot, just like a scientist. So let's look at this. I'm going to use a little tool over here, and I'm going to do this. I'm going to see if we can divide this painting into thirds. Now I'm going to do this. My lines aren't very straight. And this. So do you see this? It looks like Monet created it so that there's definitely this going on in the middle of the thirds, more over here and more over here. So I would say he followed the rule of thirds, and he also kind of moved these things around to all three so that we follow that eye. Our eye follows this pattern through all of those different pieces. So that's also another thing artists love to do. They love S's. They love to be able to take your eye from one place and follow through all of those different sections of thirds so that they're filling it and telling a story. So Claude Monet for sure used the rule of three. Whether he would say that or not, I can't really tell. So I would challenge you to look at this and read more about Claude Monet, who he was, and look at more of his paintings. But for now, I'm going to switch back over to my clicker, and we're going to go look at a couple more paintings. We're going to do a little bit of a venture, and we're going to look here at another European painting of Joan of Arc. So Joan of Arc is a historical figure, and she was just a teenager when she led the French army to a series of victories over the English. So she was pretty amazing. I would say she was a superhero of her time. And let's look at this painting. And I'm going to pull this out again. And can you see, I feel like Joan herself is right on that third. And then we've got another one right back here. So this one is almost textbook, right? So here's Joan right in the center of the third line. She's right there. So we are for sure supposed to be looking at Joan. But then in the same spot behind her in the background, we also see this here. And this might represent an angel that she was said to have seen as a vision. And so you can kind of see that little person back there, someone standing right back there. Pretty amazing, huh? So we're supposed to be looking at these two different things. The artist even made the tree here, made the lights darker here, made all the values much darker and heavier so that we were supposed to be looking at this third. And then this is kind of an after shot or more of a background space. Okay, let's go and look at one other. So those are two paintings. Let's look at a photograph, because photographs and photographers use the rule of thirds even more than painters do. So let's look at this one. This is a painting, or not a painting, it's a photograph, an old photograph that was a salted paper print from a glass negative. So a long time ago in photography, they would use glass negatives, and it was this fantastic chemical process to take a picture and then move it onto a glass negative and then to print it back out. They use salted paper, and salt is just sodium chloride, which is again another chemical compound, all about science. So without science, we could not have photography. We could go into a whole other session about this. But let's look at this and see if even in photography, they're using the rules of three. So I'm going to pull out my pen again, and you've probably already noticed with your eyes that for sure there is a rule of three going on here. And I'm gonna do this, this, and this. So it's not exact, but there's definitely over here, they leave this a little bit more open so that you've got this anchor here and it almost looks like the ship is moving forward. Then you have all of the heftiness over on this side, the heft and all of the boats and everything here. And that allows this top portion up here, this top third, to really show off all the rigging and the light. And just like he said before, you use the horizon line as part of your lines to help the viewer create and understand the story behind it. So there we go. We're going to go back to here. And we could spend all day at a museum, and especially at the Met, because we just went through 3 different sections in just a matter of minutes. But if we were at the Met, it would take hours for us to go through all of this amazing art and play this game. One of my favorite games to play is to go around and see if all the pictures are using the rule of thirds. It's especially helpful if I'm at an art museum and I'm tired and I kind of don't want to be there anymore, but my family's still there. It gives me something to look for. And I can look at everything and see how it's divided in different proportions against each other, just to see if everyone's breaking the rules or using the rules or breaking the rules. So that's a very fun game to get to play. And that's about all we're going to go through today. So I want to thank you for coming and learning a little bit more about how STEM, or science, technology, engineering, and math, can be found in the art and at the museum. I just touched the surface. There's so much more, because we could not have art without science, and we really can't have science without art. And if you come back to our Smithsonian exploration later on this year, we'll be looking at art through the eyes of science, and it's really cool. But my challenge for you right now and this week is to go to a local museum. This week, try to find a local science or technology museum in your area. These places are sometimes called discovery centers or science centers. So I work at a science center. It's called the Discovery Center of Idaho. There's lots of different ones. There's the California Science Center. There's the Exploratorium in San Francisco. Lots of different great places to go. If you don't have a science or technology museum near you, go to any other museum or nature center and look for patterns. Ask questions, observe closely, and consider how things were built or fixed, or how you could use engineering or technology to make it even better. So thanks again for coming, and I can't wait to see you next week. See you at the museum next week, where we get to learn all about how performing arts like music and theater and dance can be found at the museum. I'll see you next Monday at the museum. Bye.